This is the first video for lesson 17, and I'm going to go over exercise number 1 because it's a little bit more difficult than example 1 on the previous page. So taking a look at exercise number 1, in class we talked about this specific notation. Remember back to this entire notation. This entire notation means this is our function f, this is our function name, and our input, this is our input, and this is our output. And what this is saying is that double-lined R, we can rewrite like this, means all real numbers. So it's just a notation to make it easier to write all real numbers. So instead of writing out all 3 words, you're just writing out a symbol. So this means that the set of input numbers that we can use is all real numbers, the set of output is all real numbers. So this is what we're going to use to guide our thinking about domain and range. So this is like the starting point. So function name, input, and output. Okay, and the rule of our function is f of x is equal to x plus 2. So when we're looking at domain and range, remember domain is very much related to our input. So basically we're going to look at our function and then think about what kind of numbers can I put into this function x plus 2. I believe there isn't one specific way. There isn't like a step 1, step 2, step 3 that can like just solve these kind of questions. So you really have to just sit down and think about that function. X plus 2. Is there any number that I cannot plug into it? And if not, then this all real numbers would be my domain. So my domain is all real numbers. Taking a look at the range, is there any number I cannot get back out from x plus 2? Nope, there's no restriction, so I'm going to go ahead and also put all real numbers. And you are done defining the domain and range of this function. Okay, just as a reminder, I'm going to go ahead and use my box notation. This isn't a formal math notation. I use it just because it's a little bit easier to imagine what is going on. So here's our function f. Whatever we input is all real numbers. What we output is also all real numbers. Okay, just remember that. And let's go ahead and take a look at part B. So part B, our function name is g. Our input, we're going to start with all real numbers. And for our output, we're also going to start by thinking of them as all real numbers. And then we're going to take a look at our rule and see if that changes our domain and range. So taking a look at our domain is defined by the numbers that we can plug in as x. So we take a look at this particular equation. We have square root of x minus 1. And I want you to think to yourself, what numbers can I not plug in for x right now? So take a minute to think. Pause the video if you need to. Okay, here we go. So some of the numbers, you might just start plugging in random numbers. What happens when I plug in 2 as x? I get square root of 2 minus 1. That's equal to square root of 1. That's equal to 1. So that's okay. What happens when I plug in 0? I get 0 minus 1, which is equal to square root of negative 1, which is equal to I. But right now we're only dealing with real numbers, so this is not okay. So I can't plug in 0. So now you want to start to ask yourself, what are all the numbers that I cannot plug in as x? And that's going to be my domain. So some of you guys might take this time to go ahead and think of a formula or think of more numbers as examples to just try it out and see what works. So I'm going to go ahead and guide you through the way that you can think about it based on algebraic formulas. So if we have something like this, square root of x minus 1, remember, in order to not get a I or a complex number, we want this entire square root, we want whatever we're square rooting to be positive. Okay, so anytime we square root something that's negative, that gives us imaginary numbers, which means we want x minus 1 to be positive or greater than or equal to 0. If I go ahead and solve for x at this point, I'm going to add 1 on both sides, and what I get is x is greater than or equal to 1. So therefore, my domain now is x is greater than or equal to 1. And I can double check that. Take a look at the example here. Our example here, we plugged in 2, and it was okay. We plugged in 0, and it was not okay, because 0 is not greater than or equal to 1. So in the same way, we're going to think about the range. And in our range, we're talking about the output. So now you're thinking, if I take the square root of x minus 1, what is the number I cannot get out? Well, you know that when you screw any number, you always get a positive number back out. So therefore, my range here is g of x, my output, is always greater than or equal to 0. It is always 0 or a positive number. Okay, so I'm going to stop here for examples A and B, and then in the next video I'm going to go over part C and D of exercise number 1.